What if Earth once had glowing rings like Saturn? Not a fantasy, not fiction, but real, scientific possibility. According to recent research, for nearly 40 million years, Earth may have had a spectacular ring system, encircling the planet like a crown of cosmic debris. And here's the kicker: we might see something like it happen again. This isn't just an eye-catching theory, it could rewrite a part of our planet's history. Today, we're diving into this fascinating hypothesis that Earth once had rings, just like Saturn. We'll uncover how planetary rings form, why they disappear, and the strange new evidence that suggests our world once wore a halo of rock and dust. And what's more, this could explain one of the greatest extinction events in Earth's history. Let's begin with the basics. Rings form when large objects, like asteroids, venture too close to a planet and are torn apart by intense gravitational forces. There's a limit to how close anything can get before being ripped apart. That zone is called the Roche limit. If an asteroid crosses it, the planet's gravity can shred it into countless fragments. These fragments don't just disappear, they get trapped in orbit, forming rings. At first, these particles move chaotically, colliding, bouncing, and spinning in every direction. But over time, their orbits can flatten into a thin disk, giving rise to a ring system. As long as the debris remains inside the Roche limit, it can't clump together to form moons. It remains locked in this beautiful limbo, encircling the planet like Saturn's iconic rings. But no ring lasts forever. Slowly but surely, those particles start to spiral inward. Even in the uppermost layer of the atmosphere, the exosphere, tiny amounts of drag build up. Over millions of years, they pull the ring particles closer and closer, until they finally plummet and burn up. The ring disappears in a cosmic rain of fire. Now here's where it gets fascinating. Roughly 466 million years ago, Earth experienced a dramatic spike in meteor activity. It's known as the Ordovician impact spike. For 40 million years, space debris bombarded the Earth, a night sky filled with falling stars, again and again. At first, scientists assumed this came from a massive asteroid collision in the asteroid belt. But something doesn't add up. If that were true, then Mars, the Moon, and other inner solar system bodies should also show evidence of impacts from this time. But they don't. Only Earth was hit. That raised a huge question: why? That's where the new theory from Monash University comes in. The researchers suggest that a large asteroid about 10 kilometers wide had a terrifyingly close encounter with Earth. It passed just a few thousand kilometers above our surface inside the Roche limit. That means Earth's gravity would have shredded it. And that debris, it didn't just disappear into space, it got trapped. It formed a ring. At first, the fragments would have whipped around the planet in elliptical orbits, smashing into each other at wild angles. But those constant collisions would have slowed them down, smoothing out their paths and pulling them into a single plane. Eventually, Earth's rotation and equatorial bulge would have stabilized the fragments into a flat, elegant ring system. Some debris may have escaped beyond the Roche limit and temporarily formed small moons. But over time, tidal forces would have dragged those moons back in, breaking them apart again, and reintegrating them into the ring. But the ring didn't last. Earth's exosphere, though extremely thin, still created enough drag to pull particles downward over time. One by one, they fell, burning up as meteors and slowly draining the ring from the inside out. It must have been an incredible sight, a shimmering band across the sky, shedding fire onto the surface for millions of years. Now comes the big question: how can we prove this actually happened? The key lies in where the meteorites from that time landed. If they came from space, from the asteroid belt, we'd expect impacts to be randomly distributed around the planet. But if they fell from a ring, they'd mostly hit near the equator. To test this, scientists traced 21 ancient impact craters from the Ordovician period. These craters are now scattered across the modern globe. But plate tectonics shift continents over time. When scientists rolled back the clock to figure out where the continents were 466 million years ago, something stunning emerged. Every one of those impact sites was within 30 degrees of the ancient equator. That's not a coincidence. Statistically, the chance of all 21 craters randomly falling in that equatorial band is just 1 in 25 million. It fits exactly what you'd expect from a ring raining debris down around Earth's middle. And there's more. Not long after this ring event, Earth experienced the Hernantian glaciation, an ice age so extreme that it triggered the second largest mass extinction in the planet's history. Could a ring have caused this? Some theories suggest that asteroid dust in the atmosphere cooled the planet, but a ring system casting shadows over whichever hemisphere was in winter could have acted like a massive sunshade. It would have created longer, colder winters and might have triggered the formation of massive ice sheets across Gondwana, the southern supercontinent. That, in turn, could have plunged Earth into a deadly, icy spiral. So could Earth have rings again? Yes. All it would take is another near miss with a large asteroid, one close enough to cross the Roche limit, break apart, and start orbiting us. It could trigger another generation of firestorms, meteor showers, and maybe, just maybe, another dazzling ring in the sky. The idea of a ringed Earth sounds wild, but the evidence is building. And with more crater studies and sediment analysis, we may soon know the truth. So what do you think? Did Earth once wear a ring of cosmic fire? Could it happen again? Let us know in the comments. Thanks for watching, and remember, the sky has secrets we're only just beginning to uncover.